So a second method for performing division on polynomials is to do this thing that's known as synthetic division. What synthetic division is, very simply, is it's a fast way to do long division by only recognizing coefficients. All right, and then there are different things that we can do with this once we learn this process. All right, so the first thing that we have to do is we have to recognize that we are doing division and what we are dividing by. So if I notice right here, they're asking us to divide a particular polynomial, and I'm dividing by x plus 2. Now, this x plus 2, we should understand the concept right now of a 0. What is the 0 for what we're dividing by? The 0 here would be negative 2. I'm going to call that my box number. All right, so I'm going to put that negative 2 in a little box. Then I'm going to look at what I'm dividing by. And I'm going to list just the coefficients, not skipping any term. So for instance, if there's, and we'll see this in an example, if a term is missing, we have to hold its position by using a 0. In this case, we have 1 x cubed, we have negative 14 x squared, we have 51 x, and we have negative 54. All right, I take that first column and I'm going to bring it straight down. All right, this is what I refer to as the setup of synthetic division. From here, it's a matter of following a pattern. And the pattern goes box times the bottom, put it up above, combine. So the box, negative 2 times the bottom, 1. That gives me negative 2. Put it up above. And now I combine negative 14 and negative 2 to get negative 16. Box times bottom, that would be 32. Put it up above. Combine, this would be 83. Box times bottom, put it up above, negative 166. Combine, I get negative 210. That negative 210, I'm going to put a little box around it. Now, believe it or not, I just divided. This is called synthetic because we're taking the variables out. But now we got to bring the variables back in. My original polynomial started with x to the third, but I divided an x out of it. So if I have 3 and I take 1 out, that means that I'm left with 1. So my quotient here is going to be I'm going to be left with 2. 1x squared minus 16x plus 83. The last term that we put a box around is known as our remainder. The remainder here is simply negative 210. This is what they want us to be able to do. Find the quotient and the remainder. So let's try another one here. All right, x minus 7. What's the 0 for that? Well, the 0 for x minus 7 would be 7. List the coefficients in order. I have 1 x to the third, but if you notice in that polynomial, I don't have any x squareds. I'm going to hold that position with a 0. I have an x to the first, negative 57, x to the first, and then positive 56. I always take the first term and bring it straight down. Now I follow my pattern. Box times bottom, put it up above, combine. Box times bottom, 49, put it up above, combine, negative 8. Box times bottom, put it up above, combine, and in this case, I got 0. Now that 0 is significant because what it tells me is that 0 is telling me that x minus 7 is a factor. In other words, guys, I'm telling you, another way to do factoring is what we're doing right now, synthetic division. All right, we don't have to worry about that. What we got to do now is we got to bring the variables back in. So our quotient here, remember we started with x to the third. We took an x out. So I have 1x squared plus 7x minus 8. The boxed up number is our remainder. In this case, we have a remainder of 0. There's the quotient and the remainder. Now, another thing that we can do with synthetic division is this thing that's called the remainder theorem. And what the remainder theorem is a fast way for us to plug and chug a number. So if you think about it, I'm going to write this down, but then I'm going to show you a faster way to do it. What this is saying is, if I was asked to evaluate or find P of 3, I would have 3 to the 5th minus 2 times 3 to the 3rd minus 3 squared plus 2. It's doable to do it that way, and definitely our calculator can help us with that. But I can also use this concept of synthetic division to evaluate the polynomial. And here's how that would work. Instead of this number having to find a 0, that's our box number. I list the coefficients, making sure if any get skipped, I include them. I have 1x to the 5th. I have 0x to the 4th. I have negative 2x to the 3rd. I have negative 1x squared. I have 0x and a 2. No matter how many terms it is, synthetic division is always set up the same way. Follow the pattern. Box times bottom, put it up above, combine. 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 Box times bottom, put it up above, combine, and box it up. Now, whether I did it by plugging and chugging or whether I did it synthetically, my final answer here is going to be P of 3 is 182. The remainder theorem tells me the remainder is the answer when I evaluate or plug and chug. So let's try one more like that. I know my box number here is negative 4. I know the coefficients go 1, negative 3, negative 28. I don't have an x squared, so I got to put a 0, 5, 20. All right, bring it on down. Pattern. Box times bottom, put it up above, combine. 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 And box up the last term. Now, interestingly, if I were to substitute a negative 4 in for x in each one of those terms and simplify it, I find that P of negative 4 is 0. All right, hope this helps. Good luck. Let me know if you have any questions.